Okay, then carrying on with the assess. This is question 9. This is Jensen's speedometer. Overestimates his speed by 10%. At what speed is he travelling when his speedometer says 66 miles per hour? So let's just decode that. His speedo says I'm going 66 miles per hour, but actually that's an overestimate. So my true speed is something less than 66, maybe 60, maybe 59, we don't know. So what we got here is a reverse percentage type problem. So his speedo overestimates his speed by 10%. In other words, 100% of his true speed plus 10% of his true speed comes to 66 miles per hour that we see there in the question. So let's just work it then. Right, so I've got here 110% of the speed is 66 miles per hour. Therefore the speed is going to be 66 divided by 1.10. Of course you don't need the 0, but it's emotionally more satisfying if you have the 0 there, then it actually does look like 110%. After all, 110% is 110 divided by 100, which is 1.1. With a 0, it just looks nice. So let's just work out the actual speed. Right, I can see that 11 goes into 66 6 times. I can see straight away the answer is 60 miles per hour. If in doubt, this is a calculator unit. Go 66 divided by 1.1, you'll get 60. Now let me teach you a different way, which I never teach this in class, but here's one way we can get this to get you to think differently about it. Now recognize that you're playing with 10% plus the extra 100%, the original 100% of the actual speed. So we can do this if you like. 110% equals 66 miles per hour. That's the question. So therefore 1% is going to be 66 divided by 110, and that's going to give us 66 divided by 110. That's going to give us 0.6, what the calculator says, and therefore 100%, in other words the original amount, is going to be 0.6 times 100, and that's exactly 60 miles per hour. Do you see? There you go. So that's a different way of doing reverse percentage. Alright, you may prefer that, and textbooks tend to teach that. I tend not to do that. I just tend to get you to think about getting the first line. If you get the first line right, all you've got to do is just divide by that number right there, the multiplier if you like, and that's it, gives you the same answer. Next question. This is the price of games, question 10. Right, the price of a games console is 236 quid after a reduction of 20%. So what's the price before the reduction? It's another reverse percentage. So this is the way I would normally teach it. If I'm reducing you by 20%, you still retain 80% of your original value. So 80% of course is 0.8 as a decimal, so here's my first step. 0.8 times x, my original value, is £236. So my original value is going to be £236 divided by 0.8, and that will give me, I'll find out in a minute, 236 divided by 0.8, that gives me exactly, put pounds on there, £295. Seems right. I was £295. I've reduced by 20%, that takes me down lower. Yeah, 236 feels good. That's fine. So that's what I like. You know, get the first line right and then get the final answer. Now here's the other way I could teach you. You've got to recognise, of course, that if you reduce by 20%, you still retain 80% of your original value. So here we go. 80% equals 236 pounds. All right. Because remember, I've dropped by 20%, so I'm still worth 80%. So my 80% is represented by a price of 236. Let's drop it down to 1%, because we're playing with ratios and proportions, really, aren't we? So 1% is going to be £236 divided by 80. Let's just do that quickly. So 236 divide 80. That comes to, you're going to be surprised by this, 2.95. And therefore 100% of my original value is going to be 2.95 times 100, and here it is, £295, and that works. Compare it with that one back there. There you go. Multiply by 100, return it back to its original value, and here again multiply by 100, return it to its original value. As you can see, this is a little bit more involved than this little bit here. I prefer these wonderful one-liners really, but you can do it this way if you want to as well. And that's looking quite messy, so let's just rub that out. I was just really testing out the pen there. Okay, so that's that one. Another question then. Oops, gone too far. There it is. There it is. Okay. Now this is Debbie. Now I like this question because, well, you'll see why in a minute. The table shows Debbie's English and Maths test scores in Year 8 and Year 9. So in Year 8 she got 53% in English. In Year 9 she got 75% in English. Well done. Well, that's an apparent rise of 22% by the look of it. And in Year 8 she got 41% in Maths, and in Year 9 she got 63% in Maths. That's also 22%. Or is it? In which subject has Debbie's test score improved the most? And you've got to show you're working, obviously. Grade B rated, I think. It's gone off the grade B scale in the assess. So in which subject has Debbie's test score improved the most? Well, let's just take a look. Apparently you may be able to say, well, it's 22% each. Now think of it logically. This 22% has gone up from an original percentage of 53. This 22% has gone up from an original percentage of 41. In other words, she went up by the same percentage, but you're coming from a much lower result. Therefore, the improvement is that much greater. Well, that's me trying to decode in English what's happening mathematically. But you know the formula is going to be the difference divided by the original times 100. So that's how you're going to find the increased score. So it's going to be the difference between Year 8 and Year 9's percentage divided by the original percentage. In other words, what she got in Year 8, because she didn't have 75% in English originally, she had 53% in English originally, and that was in Year 8. So it's the difference divided by the original times 100, and that will give you the percentage required. So then, let's just test out English. What's the difference? Well, I've just worked out the difference is 22, didn't I? So it's going to be 22 over the original 53. That's a fraction. Multiplied by 100, and we're going to find the percentage increase in her English result. So 22 over 53 times a ton. Right, I've got here 41.5%. Okay, so let's just test out the maths now. 22 again over the original 41. As you can see, that's a bigger fraction than that just by looking at it, times 100. Let's just do the maths on that. So 22 over 41 times 100. Doink, there it is. I've got myself, or rather Debbie's got herself, a percentage increase of 53.7%. Right, in which subject has Debbie's test score improved the most? Most improved in maths. And we've proved it. Okay. Please note, you've got to give a conclusion. If it asks you a question in which subjects has Debbie's test score improved the most, you have to say so. The proof comes in the actual calculation of the maths, but you have to give a conclusion, a final statement, because there may be a mark for getting the correct answer, but that mark may also include you having to state maths was the best result in terms of most improved. Now, I'm not sure there's another question lurking on the other page or so. Let's have a quick look. No, I don't think we've got one. So I'm going to leave it there, and I'm going to sign it off as done. Okay.